Design media. Again, we have a lot to cover today, so we're going to start diving in. Please grab your seats and let's get started. As a reminder, this class does start at 3:20, and it would be great if we could actually start the class at 3:20 because we have a lot of stuff that we want to do today. The outline for today is first we're going to do a discussion. We have to cover, it'd be great to talk through that really great article, which I love so much, and that video, first person view, or The Future is Dead. It'd be great to try and answer some of the lab questions. Then I have to sort of give you we have to do 2 presentations today because there's a lot of stuff to catch up on. Namely, we're going to talk about pattern languages and Christopher Alexander, and I'm going to sort of show you the framework for the first big project, which we're sort of going to start assigning today, and it's going to be due in about a month from now. It's worth 20 points, so it's about 20% of the grade, and it's a big fun project that I'm really excited about, and we're going to kind of kick it off today. Then we're going to try and squeeze, we're going to see how much time we have. We're going to see if we can squeeze in the lecture from last week about crafting compelling narratives in XR spaces. And then I'm going to try and transition us into doing some of that stuff in Godot. And we're going to look at how to import models, how to play animations, how to do some spatial sound and light and fog, and really start trying to, we've done a lot of some sort of bare bones Godot stuff, but it'd be really nice to start being able to build some kind of immersive environments, right? Being able to sort of actually create experiences that sort of feel and taste and sound like interesting narrative environments to immerse yourselves in. Any questions or concerns before we start jumping into all that? No? Okay. So, this article, MirrorWorld. What did you all think of MirrorWorld?
It was interesting.
It was interesting? What was interesting about it?
Talk about time in the mirror world as being like kind of, you can change it.
Yeah, right? You can change time. What is it? There's this really good quote. Let's see if we can find it in here. Boop. Why can't I word search today? Oh, because I'm on a Mac. Okay. Time. Time is a dimension in the real world that can be adjusted. Unlike the real world, but very much like the world of software apps, you will be able to scroll back. What does that mean? What do we think that means?
Well, I was going to say that the thing I thought was interesting about it is that, like, you were asking, like, how we can define, like, the metaverse or whatever.
Yeah.
And I feel like the way time exists in it is a good way to separate it from, like, the real world.
Yeah.
Because everything's kind of static in a way at the same time because all the information still exists in there.
Yeah, right?
You can just access it at a different time.
Yeah,
you
can travel back in time by sort of accessing, right? I think this he was talking specifically about like this idea in augmented reality of having like, memories or events or media attached to specific points in space. So if you go to like your favorite park bench, you could scroll back in time and see the time you sat there in the winter, or you might be able to use an app to like predict what it would look like in the future or something. And there's something really powerful about like taking this data and bringing it into space in our real world that kind of makes it feel like the world has this weird quality of making time reversible. Does that sound crazy to anybody? Does that seem possible in an XR centered future, or does it seem like baloney?
Makes sense to me.
Makes sense?
I was thinking of it more in like a really like basic sense, I guess.
Yeah, what's a basic sense?
Well, what you were saying just now, I mean, you're not really like changing time in the real world.
Right? It's
like,
an illusion,
it's already
yeah.
there.
Yeah.
I don't know.
No, it's a really good point, right? All of this, it can make you feel like you're going back in time, but you're not actually going back in time. Just in the same way, you can conjure all these images and these phantasms of, floating things in space or whatever, but they're not actually there. It's all kind of illusions on some level. What about the idea of, like, there's a real emphasis on cameras in this article. Does anybody understand why they talk about cameras so much and these tiny little cameras?
Yeah, was it? They were talking about these cameras that, or well, eventually how cameras would become so advanced that would be like the size of an atom.
Yeah, it's crazy idea that a camera will be so advanced it'll be the size of an atom. But like, that's cool that can happen. But like, why is this guy saying that that's essential for the mirror world to exist? Why do we need a bunch of cameras everywhere?
It's a lot of ground to cover.
It's a lot of ground to cover. Like, in what way? Like, we have to like what do you mean? Like literally, we have to like see a bunch of stuff?
But you need that data to create the whole thing.
Yeah.
You can't just like conjure up unless you hand texture everything.
Right. Well, and things change all the time, right? Like if I move my car, if I park in one spot and we take a picture of it and make a mirror world based off of that, but then I move my car, then it's kaput and we have to start all over again. So you need this kind of constant like surveillance of everything. It's really crazy, and I think the craziest part is that like it's pointing. I think like why I really like this article is that it points at this idea of a metaverse or a mirror world so much kind of bigger in scope than what we typically imagine, right? Ready Player One, it's like there's this virtual world, it's somewhere else, but like this is talking about taking a whole digital world and applying it on top of our existing world, and everything in our existing world will be part of this digital world in some way, and there'll be digital twins, right? Digital equivalents, and we'll have to like, it's only when you really sort of get stuff at that scale that then you can really start to have this kind of magical thing appear where like you can interact with all these digital objects that actually exist and correlate to things in physical space, right? And there's this idea that we have to like map things one-to-one with digital twins, and in order to like capture all that, you need a boatload of cameras. You need cameras kind of everywhere. It seems very dystopian, right? As it says here, there's like, where is it? I remember major privacy. Yeah, major. It will raise major privacy concerns. It will, after all, contain a billion eyes glancing at every point, converging into one continuous view. The mirror world will create so much data, big data, from its legions of eyes and other sensors that we can't imagine its scale right now. To make this spatial realm work to synchronize the virtual twins of all places and all things with real places and real things while rendering it visible to millions will require tracking people and things to a degree that can only be called a total surveillance state. Yikes! That's like a big yikes, right? That's kind of really crazy. And that seems like a really, really huge drawback. Like that sounds terrible. Do you guys think that drawback is worth the promise of like a mirror world? Is that trade-off worth it? Should we try and make that?
I don't think so.
You don't think so?
I wrote in my reflection like a similar thing, and I think if this did exist, it would exist in like a really commercial heavy zone where there would be a lot of robots who would need like a.
Wait, when you say commercial heavy zone, what do you mean? Like a lot of like
just somewhere like downtown.
Like Times Square.
Yeah.
Yeah.
But not.
Yeah, there is something kind of commercial about that, right? It's very public space. It's all very, I don't know, commercial is an interesting word. What makes it commercial?
Or maybe somewhere with like a lot of construction.
There's definitely a lot of use cases for, like if you have a very dangerous environment that you can't send humans into, robots are a great way to go in there and navigate that environment, and you can sort of be on the outside. If you're like, if there's if a nuclear reactor has a meltdown, right? They already do this. If a nuclear reactor has a meltdown, they'll like send a robot in and then manipulate the robot from afar. And increasingly, right, we see that like they talk about GE as being a.
I know that they do this in like refineries and stuff.
Yeah.
You're not people are not allowed there. It's like it's too dangerous.
Right. Yeah, it's too dangerous. Or like this idea of things having digital twins started with NASA, right? When they would send things into space, literally you can't be up there in space, so they would make duplicates of all the machinery. They'd make physical copies of all the machines and put them down here on Earth. And then when they're trying to fix things, they would like fix them. They'd have the astronauts or whatever do the maintenance up there, and the scientists do the maintenance down on the Earth, and they would match it sort of one for one, right? And it's the same sort of thing, like in refineries or like in power plants. You sort of increasingly people are working with the digital equivalents of the actual thing, right? We're not actually working with physical objects. We're working with like digital twins of physical objects. So there's real use case for something like this in that sort of environment. But is there like a broader, like, does it make sense to try and have this in a broader context? Like this idea of like a vast digital world on top of our physical world? Does that seem, if it comes with so many privacy drawbacks, like what are some of the positives that could come from it? Yeah.
I think it would work well as like just kind of like a bit more of a flushed out Google Earth type of deal.
Yeah.
Because people, nobody really talks about the privacy issues of Google Earth.
But it's taking pictures, right? Like my house is on Google Earth. I'm like, how did I get there?
It's weird, but I don't think you can really avoid that.
Right.
But if you do have like a one-to-one world, I think it would be wise to kind of like scan zones when there's no people in it. Which, when it comes down to something that could be like updated frequently,
Yeah.
that would mean that there'd have to be like zoned off sections of time where you're not allowed somewhere.
Right. Like 1 a.m. Nobody, everybody get out. We got to just
Everybody has
scan.
to get out.
That's interesting.
Scan it.
Yeah. That's sort of an interesting compromise.
I don't really see much of a use for it outside of things that like Google Earth can already provide. I think it would be cooler if it was more personal. Like the technology became a lot more user friendly.
Yeah.
And you had the option to, if you wanted to do something like with a note, like when you're walking, like if you wanted to do that
Right.
in your house or something.
Yeah.
I think that people should be able to replicate that by themselves.
Yeah. Yeah.
And
Like you could leave a physical note for yourself somewhere in your walk or in your
like
house.
a family member
Yeah.
or a friend or roommate. That'd be kind of tacky. Like I'd be really pissed off if a roommate left me like a digital note, like, oh, clean the dishes.
It'd be really passive aggressive, right? And why not just leave a physical note?
Tell me, call me.
Right.
Like, if you want to talk to me, just talk to me.
Yeah. Yeah, just like we don't need to necessarily use all this technology and stuff. We can just use our words. There is something really powerful about the idea of being able to go back in time. Like you can leave a note for yourself in the future, or your friend can leave a note for you in the future, right? Or if we have really realistic like video conferencing that's fully 3D or whatever, that can feel like you're teleporting, right? And I don't know if any of you have family members who live far away or whatever, but the ability to like be in the same space with them digitally and actually have it feel like you're sharing physical space with them, that's a real powerful upside, I think. And there's all sorts of applications with like sort of creative, there's all sorts of art that we can make that it would be impossible to make in the real world. You can have sort of whales flying down the street, right? Or you can sort of enter any sort of, right, Ready Player One style world. There's all sorts of things that you can do, but there are some real concerns about how the technology that we need to get there. And that's why this article does a decent job of emphasizing the importance of a decentralized. Is this the only instance? Oh, one of three. A decentralized model, right? Without exception, every researcher in this field that I've spoken to has been acutely aware of these divergent paths. The divergent paths meaning like we could make a metaverse or a mirror world that's tightly controlled by a couple of big companies, or we could make one that's sort of decentralized and more open. Welcome. No worries. But right, without exception, every researcher is acutely aware of these divergent paths and claims to be working towards a decentralized model for many reasons, including that the chief one, that a decentralized platform and open platform will be richer and more robust. Clay Baver, Vice President of AR and VR at Google, says, "We want an open service that gets better each time someone uses it, like the web." So like, what do you are you all familiar with the idea of like a centralized platform versus a decentralized platform? No? Yes? No? Let's just Google it. They go over it a little bit in the video. Like, what do they go? I guess it's called Decentraland in the video, and it's sort of it's a really interesting comparison. But this is sort of standard. This is standard language for network analysis. Any sort of a network is sort of any sort of collection of nodes connected together into a pattern. So like the internet is a network. Your social network is a network. There's lots of different types of networks. I'm trying to find a good picture. And this is a pretty good example. So in a centralized network, there's sort of like a variety of different types. But in a centralized network, there's one sort of thing that connects everything together. There's one or a few major players that connect everything together. And you can think of a centralized network like a lot of the big tech companies today. So like Google is a centralized service that everyone has to use, right? In order to find, before ChatGPT or Bing's sort of, for like the last 10 years or whatever, Google has been like the main way that we find stuff on the internet. So everyone goes through Google, right? Or if you want to buy something online, you go through Amazon, you use Amazon. A decentralized network is more like the web itself. The internet itself is all these different connected apps and services, right? Like, so you have like Reddit over here and like YouTube or Discord, or you have Craigslist, right? You have all these different things that are connected in a network, and users have the ability to access one of them or access another one of them, but you don't have to go through a central intermediary, right? And then a distributed network is even more spread out, where there's even more connections between individuals and major hubs alike, and there's not really a difference between hubs and individuals. And the internet itself is a lot more like this model and this model. Particularly when the web first launched, it was a lot like this. It was just sort of everyone hosted their own website, and your computer would call up somebody else's computer and get a website from somebody else's computer. And it was all very spread out and interconnected, and it was based on a groundwork of open standards of communication, open protocols like HTML and HTTP, and being able to like share information with standards across different companies and websites and stuff. And over time, over the last 10 years, since really since smartphones took over, right, we've got launched into the world of apps and sort of like closed ecosystems where you have to, how you can't like share something from Facebook onto Twitter easily, right? You have to take a screenshot, right? Or you can't share things from TikTok to Instagram very easily. Can you do that? I'm actually not on either of them. You think you can? Okay, well maybe I'm wrong. But like for instance, if you have followers on Instagram, right, they don't just translate into followers on TikTok, right? You have whole separate audiences, you have whole separate streams of content, right? And it's all sort of separated off. And that, I'm going to be biased here and say that model is really bad. That's my strong opinion, and you can challenge me on it. But it creates these systems where, like, when you have these sort of closed ecosystems that don't allow other ecosystems to integrate and communicate with them, that's where you get sort of services that eventually become really shitty for everybody. Like Amazon, for instance, eventually gets really shitty for everyone, where the people who are selling things on Amazon get screwed out of profits because they're flooded with competition. People who are buying things on Amazon get screwed out of buying good products because they just get sort of junk products promoted to them. There's all these sort of real downsides to this sort of centralized model. And what this article is kind of arguing for a little bit is to, in whatever next big thing that we're building, the next metaverse or MirrorWorld or whatever, it's really important to folks that we create that in a decentralized way, in a way that feels a lot more like the internet as a whole, rather than just using something like Amazon or just using something like Google, or just, one company shouldn't be allowed to rule the metaverse, because then they get to set all the terms and spy on you and steal all your data and do all these bad things, and you're sort of locked into this negative ecosystem. Does that make sense? That was a bit of a tirade. But
How do you avoid that? Though?
how do you avoid it? That's a really good question.
Won't
It's
they be the ones making the?
well, that's why we're doing this class, because like hopefully you guys can make some stuff and not like be jerks about it. I don't know, like there's I think that's what's really important about sort of open source software and knowledge sharing. With these sort of open protocols and standards, like sharing information freely is a thing, right? The internet is built on this idea that that there's like a shared language that we have. All web pages are made in HTML, right? Like this web page itself, if you were to inspect it, you can open how do I open the inspector? File, and oh, you think so? Yeah, that could be it. I'm in Firefox, so inspector. Console. You guys know what I'm talking about, though, right? You've seen web pages. They're all made out of HTML. I thought it was Command Shift Option I.
I think you have to activate
Oh, wait, there we go. There's a shortcut you can do. I just forget what it is. But right, here's the code for this web page that we're on itself. Here's all the scripts that it's loading. And this is like a standard that that every computer in the world understands how to read. And it's by sort of creating these open standards of communication that's what allows for a really open ecosystem to emerge, is by having these kind of agreed upon rules and patterns and standards. And then sharing that freely and not letting anybody own that, right? Nobody owns HTML. It's public domain. It's a thing that we are all allowed to understand and use.
Are any languages
That's a good question.
Good
Well, Godot is also Godot is an open source program. So if you want, you can make your own version of Godot and do whatever you want with it. But there are programs like I think certain, like Go, for instance, is a language that is spearheaded by Google. But a lot of computer programming languages are in fact open source. So languages aren't really so much the problem. It's really the tools and the platforms that are created with them, right? Yeah. Any other thoughts on MirrorWorld before we move on? We can talk more about it next week too. Cool. I'm gonna keep pressing ahead then, because there's so much to do. Well, I guess real quick, did folks have thoughts on Decentraland, the video? Have you guys seen Folding Ideas before?
That's funny.
He's funny. He's really good. He's also hard to follow sometimes. He has a lot of things going on. But he is really funny, and that whole video is worth a watch if you want like a really good popcorn eating takedown of this shitty Web3 app. And Decentraland is really interesting, right? Because it is technically decentralized, but it's through this whole thing called the blockchain, and it's powered by cryptocurrency, and the whole thing stinks of a Ponzi scheme and feels kind of gross. So the question is, right, how do we make open, decentralized experiences without making them fall into the trap of finance and sort of cryptocurrency and speculative markets? I don't know. It's sort of an open question. Let's jump now quickly to just reviewing any questions you guys have from the labs. Do you have any questions from the labs? How are we all doing on the labs? I've seen about half of the class has turned in lab 2, which is good. There is no tight deadline on that, but doing it will really help you get ahead and help you understand what you need to do for the next set of projects, and we're going to start kind of accelerating, so I recommend trying to stay on top of that stuff. But yeah, any questions on the labs?
I guess I haven't been building any worlds in Godot.
Yeah, that's okay. We haven't really been, that hasn't really been assigned yet, but today we're going to start kicking that off. The assignments so far have mainly been focused on trying to build up a little bit of coding proficiency, and so now we're going to use that those skills to try and make a bit of a world, so to speak. Yeah. But I don't think we ever actually fully covered signals in class, and it'd be good to go over that so that you have it. So I'll open up Godot and we'll do a little signals demo. And bravo, yeah, for those of you who did take a stab at signals and sort of just tried to figure it out online, I really appreciate you for doing that. And for those of you who have like done stuff with signals, what did you guys do to learn about signals? How did you figure that out on your own? What resources did you find? YouTube? YouTube is pretty good.
I looked at yours too, and
Oh.
I thought because you uploaded one, I thought
You did, yeah. I looked at it. With
Yeah.
the button.
the button.
Yeah.
Oh, the code.
Yeah.
Yeah, okay, cool. Yeah, I uploaded the code. I was like, I don't remember making a video. So YouTube, you looked at my code. That's great. Any other examples of things?
Forums.
Forums. The forums are really good. Any particular forums?
Like the Reddit.
The Reddit. Yeah, the Godot Reddit's pretty good.
I think Godot has one too.
The Godot forums have had a sort of weirdly complicated history, but there's now officially a good forums here. I believe this is the latest and greatest iteration of the forums. So forum.godoengine.org. Has anybody looked at the documentation for Godot?
Oh yeah.
Yeah?
Yeah.
It's a little glitchy though.
It's a little glitchy. It's a little glitchy. The searching isn't great, but it's really robust. It's got a lot in it. So if you ever want to find the documents for Godot, documentation is like the built-in handbook for how to use anything. Lots of languages and environments have documentation. Like everything, it's always evolving and changing. But if you want to find out about signals, right, there's this whole getting started section if you want to sort of get introduced to different things. And I remember in this first 2D game, there's a nice little section on signals somewhere. Maybe not. But there's all these sections that you can sort of open up and plug into. There's all these different sort of like all sorts of stuff, right? And then if you want to find out about any node or like object in particular, you could also do that. So if I wanted to learn about the timer node, I could just search for timer, and then I could click the icon here that says doc that lets you know that it's like an official part of the like object tree or whatever. And this will tell you all about the timer node, right? And it'll link to any tutorials that use the timer node. It'll show you the different properties that the timer node has, and methods that it has, and signals that it emits. It has all this stuff. But if you wanted to learn about signals, you could search signals, and we'll see what they come up with. They have like a bunch of different things. Using signals is probably a good one. So I don't love this searching feature. Like, it doesn't necessarily pull up the most relevant result that you want, but it does. This documentation does have a lot of stuff. So if you like reading, you can sort of read through this whole little tutorial of how to like actually use signals, and it gives you a whole deep dive on how to use them. But I'll also go over it now. Oh yeah.
I also kind of use ChatGPT.
That's okay. Using ChatGPT is totally all right. It just can be a little dangerous sometimes because ChatGPT can kind of make shit up, and if you don't really follow closely, like it, you might not notice that it's making up stuff, right? It might tell you to use a function that doesn't actually exist, particularly with Godot. Particularly if you're not using a paid version of ChatGPT and it uses the older knowledge cutoff, the Godot syntax and code base basically has changed a lot in the last year and a half. And so if you're using an older model, it might give you irrelevant or older results. So it's just really important if you're going to use ChatGPT or a language model to check your work and to make sure that it's doing it correctly, right? And I really recommend not just copying and pasting from ChatGPT, but trying to type it out in your own words. And that goes true for just like copying tutorials or code off the internet in general. It's always better to type it out yourself because you can kind of get a stronger sense of what's going on. ChatGPT is really good at giving you like structural ideas, like advice on how to structure your code or like how to solve like a problem in code in general. But when it gets to the Godot specific stuff, it can sometimes lead you astray. So just be careful with that. Yeah.
I also noticed on YouTube, I watched, like for the lab, I wanted to do like a controllable WASD, a character body.
Yeah.
And I did that for each of the labs. In the first lab, the tutorial was older
Uh-huh.
than the second one, and like, there's some things that Godot has added.
Yeah, that's a bit of a downside with Godot, is that because it is the newest version has been such a big departure, some of the old content is not good. So if you're going to watch stuff online, it is really helpful to make sure you're watching stuff that specifically says Godot 4, or basically as long as the content has been made within the last like 2 years, you're probably pretty good.
Yeah, so I ended up doing, one of the weeks I ended up doing a bunch of work that I didn't need to do.
Yeah.
Because there's like now built-in stuff to do that.
Yeah. Well, I mean, you know, I guess it's helpful that you sort of did that, but yeah, you can get sort of led astray by that. So that's a really good note.
Most of the stuff that I found on YouTube,
Yeah.
that was like a little more latest,
Uh-huh.
was in 2D and not
In what?
3D. Like
In 2D?
Yeah.
Yeah, that makes sense. A lot of the 2D stuff is really applicable to 3D. Like, for instance, so I'm just going to make a demo project. I'm going to call this Lab 2 Review, Signals, and Input. I'm going to put this again into the repository. So you should have access to this in the code for the actual syllabus if you want to clone the repository itself. I'm going to put this in the sessions folder, class 5, and I'll select that folder. Okay, and I'll create and edit it. Cancel, create a folder. Okay, create and edit. Yeah, so for instance, right, if you are looking at something and the tutorial says, like, it shows you, like, something for Area 2D, right? Area 2D is very similar to Area 3D. It's just a 2D version of Area 3D. And a lot of the nodes have, there's a collision object 2D that's the same as the collision object 3D. There's an animated sprite 2D. There's also animated sprite 3D. And to be honest, you know, in the fall I'm going to be teaching a game design class that's also going to be heavily Godot based, and it is in some ways ideal to start with 2D and then transition to 3D because 3D is like a little bit more complicated. We're sort of glossing over 2D in this class because it's XR focused and it's sort of 3D focused. But a lot of the 2D tutorials, you can fairly easily translate some of that stuff to 3D. But it's a good point that a lot of the tutorials are in 2D. There's some particular tutorials that I really like that I've linked to in the syllabus. So, like, this guy G-Wiz, he's a young scrap. I think he's younger than you guys. So he's a little silly sometimes, but he also just makes these really good, like, short, tight tutorials. Like, each one is, like, 3 minutes long, and it's on a very specific topic. So, like, if you want to find specifically, like, how to use groups, or how to make a state machine, or how to use how to do multiplayer in 3D, or how to use the path node, or how to use a top-down controller, or how to make a video player, right? There's like a lot of really nice tight tutorials. There's also Lucky makes good tutorials. This guy Godotineers has this weird little robot logo, but these are all very elaborate and nice, robust, good content tutorials. And then if you're specifically trying to look for XR-related tutorials, these are people to go to, specifically Malcolm Nixon and Bastian Oleg. These are like two of the main developers of Godot XR itself, like the XR parts of Godot. And so watching these tutorials is a great way to sort of get up to speed with how to actually do some of the VR and AR stuff in Godot. But let me just show you how to use signals and input nice and quickly. let me first just make sure. I tried to squeeze in so much this week because we missed a week because of the snow, and I'm sad. But that just means that we got 10 minutes. Yeah, okay, great. Yeah, so signals and user input, right? So, so again, a signal is just a way to connect one node to another node, right? Nodes do things, and they have like events that happen within them. And when those events happen, you can sort of like broadcast a signal. So a node sends a signal out, and then another node can listen to that signal and respond to it, okay? So I'm just gonna make a basic 3D scene. I'm gonna add a classic camera, just so we can see what we're doing. I'm gonna move it back a little bit, and I'll add a directional light. Yeah.
A quick question about signals.
Yeah, totally.
So signals is a way for you to connect two different nodes, right?
Uh-huh.
But when you send one signal, you can send them to multiple different nodes, right?
Yeah, think about it like, you know, a signal is sort of like you're just like if I'm trying to send if I'm trying to send a signal and I have a walkie-talkie, right? And I'm like, it's me, John. I'm getting hungry. I need to eat lunch. Over and out. You know, I can just send that to the walkie-talkie and it'll go out into the universe. And nobody could listen to that signal at all, right? Nobody could be tuned in. But if you are like waiting and you're like, I don't know what this hypothetical is, but like let's say you have a walkie-talkie and you're waiting to buy me lunch, right? And you're like listening, you tune into the channel, and then as soon as you hear me say, I'm hungry, I need lunch, you're like, okay, I'm gonna go get John lunch, right? So you can listen to my signal. The restaurant that we're gonna go to could listen to our signal, and they could be like, oh, John's hungry, let's start making lunch, right? So anyone can tune in to like the walkie-talkie channel and listen to your signal, and nobody can tune in, right? You can just sort of send signals out into the ether, and if nobody's listening, they don't really do anything. Does that make sense?
Yeah, but then do the people who get the signal, can they all act differently?
Can they all what?
Like do different things?
Yeah, totally. Yeah, so everything can do different things depending on what, you just have to specify it in the code. So I'll show you an example. A very simple one is the timer node. I'm going to make a timer. Okay, so this is a new. Have we used the timer node yet?
No.
It's pretty simple. It's just called timer. It looks like a little hourglass. It's neither a 2D nor a 3D node. It's its own category because it doesn't appear on screen. It's just a thing that has a countdown and counts down. So you can sort of specify how long you want it to count down, how long you want it to wait for. So we'll say 5 seconds. And you can specify whether or not you want it to start automatically, and you can also specify whether or not you want it to repeat or not. Okay, that's what, if it's this one-shot property, if you toggle that, that means it's only going to happen one time, and then it's never going to go again. But by default, it's going to sort of it's going to go off every 5 seconds. Okay, and when the timer finishes, what it does is it emits a signal. So if you go to node and you see this timeout signal, this is going to be the signal that that gets emitted whenever the timer finishes timing out. Okay, so in order to actually see this signal like do anything, we're going to have to create a script. Okay, so I'm going to create a new script attached to the root node, and I'll just call it script. And hit create. I can delete all this boilerplate stuff. We don't really need it. And there's a bunch of different ways to connect signals to each other. Some of you guys did a very advanced thing and sort of connected it via code. That's great. I think the easiest way to connect a signal to another node is like this. So click on the node you want, then go over to the right-hand panel and open up the Node tab, and then go find the signal that you're looking for. This is the timeout signal, right? And this is the signal that the timer is going to emit. You can hover over in there. It says what it does. It emits the signal when the timer reaches 0. So you find the signal you want, and then you just double-click on it, and it's going to pull up all of these other nodes in the scene tree which you can connect it to. And the only one that you can only connect it to a node that already has a script attached to it. So you'll see that these nodes don't have a script attached to them, so you can't connect them to each other. This one does have a script attached to it, though. So you can hover over it, and then you just click Connect. And then you'll see what it did is it sort of, that's a little sort of function that does a couple things for us. Firstly, we'll notice over here, it shows you what the timeout signal is connected to. So if you double click on this, let's see, I think if we were somewhere else and you double click on this, it'll open it up to the point in the code where it gets connected to. You'll also see that it added this whole little line. It added this function that says on timer timeout. And this function currently doesn't do anything, but you'll see that it has this little green symbol. This means that this is a callback function that is connected from a signal, right? So this means if you click on this, it'll show you the timer signal emits the timeout signal and targets this node 3D. Okay? Does that make sense? And so then, whenever the timeout times out, it's going to emit the signal, and this part of the code is listening for the signal, and we can do stuff here. So right now, I'm just going to print out timer is done. Okay? I'm going to save this scene, and we will run this project and select the current scene, and then we'll see 1, 2, 3, 4, 5, 1,006. Well, I was counting a little fast. The timer is done, right? The timer finished. It fired the signal over to this node, which printed out this thing, right? But let's show you what happens. And right, because we didn't have the one-shot property checked, right? Because it's unchecked, you'll see that this is going every 5 seconds in a cycle, okay? And again, right, while our project is running, we can adjust this. So I can actually like shrink this down, and we'll see that it starts going, I think, a lot faster, right? Or we can make this, you know, slower, and it'll go like every 38 seconds now, which is a very long time. But let's do a simple example of like making multiple signals, multiple nodes respond to a signal, okay? Because right now we have one node responding to this signal, but yes, you can have as many nodes as you want responding to signals. So I'm gonna just add like a sphere, CSG, I'll just do mesh. You don't even need a CSG. I'll just do a mesh instance 3D, and I'll give it a mesh of a sphere mesh. I'll go back to the 3D view. That looks pretty good. So then now I will just stop and start the game. Okay, so yeah, we see this sphere hovering here, right? So what I'm going to do is I'm just going to go back to timer. Well, first I will add a new script to the mesh, right? Because everything that we attach a signal to needs to have a script. So I'm going to do attach a script. I'll call it mover. And then back in timer, I will go to node. I'll double click on timeout. And instead of clicking on node 3D, I'll just click on this node as well, and I'll hit connect. And we'll see that it added this function down here, right? And we have these two different scripts now. This is our script attached to this node that prints the timer is done. And this script is attached to this node. And we'll just make it move the sphere. So we'll do position dot y plus equals 0.5. And I'll save that, and we'll run the project. And now, when the timer times out, it should both move the ball and print that thing out. Okay? So yes, it's really easy to have signals connect to different nodes and to have different nodes do things at the same time. Okay? Any questions on any of that?
This is such a weird thing that's not even really related, but
No, go for it.
on the code, for some reason, in my lab too, it wouldn't let me, like, nothing would work unless I had the pass line.
Yeah, so if you
What
have,
does that even mean?
like, did you have,
I don't know, like, when I press play, like, none of the code would work, and then for some reason when I added that in again, it, like, started to work. But maybe it was unrelated, I'm not really sure.
Yeah, the pass line, you know, it might have been if you had, I'll take a look at your lab in general, but if you just have, if you have a function that doesn't have anything in it, like this, it's going to be annoyed because Godot needs, if you're going to go to the trouble of declaring a function, Godot wants to know what it's supposed to do with that function. Right. So if you have an empty function, your best bet is to either have pass, so you can just sort of say, hey, skip this function, don't do anything, or you can just comment out the whole function or just delete it, and then you don't need it.
I remember now if it was in a function I was using.
Yeah, we can take a look at it.
It was probably not the anyway, sorry.
That's all right. The last thing I'll show you in this lab is, again, how to do user input, right? So, and in order, does anybody remember how to do user input?
Mm-hmm.
Yeah, what's some of the process for doing user input?
Is it you go to scene and you have to like set the actual input?
Yeah, so first we can go ahead and go to our project settings, and then input, and we're going to create some mappings that we want to use, right? So I'll just do 2 right now. I'll do a left and a right. Okay, and then what's the next step to get these actually into our code?
Input is action press.
Yeah, right. So we create an if statement, and we want to do this inside of our process loop. Does anybody know why we want to do this inside of our process loop?
It's repeating on every frame.
Yeah, we want to check every single frame if we're pressing down the button, right? We don't want to just check one time. We want to check every single time we're pressing our button. So we can say if input dot is, and then you'll see, right, we have all of these different possible options. So we can do is mouse button pressed. Let's do mouse button. Well, we already defined our left and right. But you can do mouse button presses. You can do, there's all sorts of like if events that you can sort of query for. And these functions are going to check a state. They're going to check whether or not the mouse is being pressed. Like right now with, let's see, is action just pressed. I'll do is action just pressed, and I'll say left. So this function is going to check, is this action left being pressed right now? Has it just been pressed to this frame? And if it has, it's going to return true, which is going to make this if statement execute, right? Because if statements execute if they are true, right? If this condition evaluates to true. So if the input is just pressed, if this left button is just pressed, let's move the position dot x minus equals 0.5, right? And I'll do the same thing with the right. So I'll do if it is pressed right, and we'll do plus 0.5. And I'm going to change this moving to Z so that it doesn't fly off the screen, so we can keep looking at it while we do it. So now I'm going to run the code. And now, oh, we don't, it's actually not going to do anything because we forgot something very important. Does anybody know what we forgot? Right, we can't just name these things. We have to assign these to actual keys or button presses. So in order to do that, we click this plus sign up here. And then you just type in the, if you're doing a key, the best thing to do is to just type in the key that you want to be the key. If you're using like a game controller and you have it like connected, you can also press a button on your game controller. Or we could click right now. Actually, yeah, let's do that. I'll just click the left button. So I'm clicking the left mouse button, and then I hit OK. And then I'm going to go over here and I'm going to click the right mouse button, and I'm going to hit OK. So now every time I click, it's going to trigger this left action, and every time I right click, it's going to trigger the right action. So now if we run the code, and I click, it moves to the left, and if I right click, it moves to the right. And interestingly, right, if I click and hold, it doesn't keep moving, right? Does anybody know why it doesn't keep moving?
It's because it's on action just.
Right, yeah, that's correct. It's on is action just pressed. Did this happen one time? So this is action just pressed is really good for detecting like the first time something happens. So if you want to click on something, for instance, or if you want to like just jump one time. But if you want to like move and keep moving, then it's better to use is action pressed. That's a good one to do. Instead of is action just pressed, you can do is action pressed. And this is going to check and see if you click. And it's also going to return true if you're holding it down, like if you're continuing to press the button. So now, if I click and hold, you'll see that I fly off the screen, because that's a very big increment to move every single frame. So I might want to like make this a smaller number, like 0.1. And there we go. Now we have a thing that moves when I'm holding down the mouse, right? The final cool thing that you can do with signals is you can create your own signals, and you can emit them whenever you want, okay? So in order to create your own signal, I'm going to go up to here and say, just write the word signal, and then followed by the name of your signal. I'll say moving left. And then when you want to emit that signal, all you have to do is go to the part of the code that you want to have execute that. So I'm going to have it, you know, when the ball is moving to the left, I'm also going to say emit signal, so EMIT _ signal. And then it's going to show you all of the built-in signals, but you'll also see the one that we made. There it is, moving left. So I'm going to go and say moving left. And you can also pass along any sort of information that you want at this time. So I'll even pass along the position that it's at. So I'll do position. I'll pass along the position, okay? And then if you want to connect that signal to another node, it's the same process. So I'm just going to click on this node. And you'll see over here in our signal section, we have our new custom signal that we created. So I'll double click that. And I'm going to connect it back to our root node and hit connect, okay? And here we have on mesh instance 3D moving to the left. Then this code is going to happen when we use our custom signal. And so I'll say, like, I'll print out we're moving to the left. And so now when we run the code, right? When we move to the right, it moves to the right. When we move to the left, it moves to the left, and we get an error because I messed up something. What did I mess up? I think I know what I messed up. Why is it so big? Yeah, okay. So it says the method was expected 0 arguments, but was called with 1. That is because I passed in this position value. So if you want to use this position value correctly, like when you're sort of receiving the signal, you also need to like catch it, right? You can't just send out extra information with this signal. You also have to receive that information. So in my other script, I need to add the word position here. And then I think that should fix it. Yeah, now it says we're moving to the right, we're moving to the left. And if you want to access that position from this script, right, you can just you can just access it. So you can just say print position. And does everybody remember like this syntax where we sort of put something inside of parentheses in a function? I covered it briefly. Huh? Parameters. Yeah, this is like a parameter. This is a thing that you're passing through to your function. So this is something that comes into your function, and then you do stuff with it. And what's key is, right, I used the same word position, but you can use any word here so long as you make it match. So I'm going to call this like my position, and that's fine. And then I can just print out my position down here. So then I'm going to save it, and now, right, when we move to the right, it moves to the right. When we move to the left, it moves to the left, and it prints out the position, which we're passing from the signal to the node. Does that make sense? This is all pretty technical, right? Again, you know, I'm going to post this code online. I'm also going to post this video online, so hopefully there should be a lot of resources for it. This has all been pretty technical, but like the point is that we're going to start trying to use this to actually like be creative and express ourselves. Yeah. So that's the sort of stuff you need to do for Lab 2, is just use a signal and use some user input and have nodes communicating to each other and post it on GitHub. Okay? Let's go back to GitHub now and take a look at the syllabus once again. Yeah, a little bit behind. That's okay. Oh my god. Okay, yeah. Yeah, so we want to start like actually building some things, right? We have talked a lot. We've done a lot of small technical examples, but we haven't really sort of had them cohere together into anything larger until now. And I think that this lens of pattern languages is a really great way to start thinking about how to create some larger XR experiences kind of gradually and with different building blocks. So that's not the slides. Those aren't the slides. Are these the slides? No, I didn't link the slides. Let's find the slides. Slides. Okay, so yeah, did anybody dare to take a look at Christopher Alexander's stuff? Did anybody catch that I asked you to read 2 whole books? It was... That's great. Yeah, I could, whenever somebody in college would say read a whole book, I'd be like, oh, no, I'm not going to do that. I'm not going to do that at all. But skimming is an art form, and I'm wondering if any of you had a chance to skim it. Did anybody, in skimming it, or even just kind of encountering a little bit, like, who is this guy? Why are we talking about him? What's the deal?
He's an architect.
Uh-huh.
And has like a particular way of building things. Methodically and thoughtfully. It's kind of confusing.
It is kind of confusing, right? Is anybody else confused by it? What about down at this side of the room? A little bit? A little bit of Christopher Alexander? Yeah, he does have this sort of weird way of looking at the world. Christopher Alexander was an architect who lived from 1936 to 2022. He just passed away recently. That's a building of his on the right. It's very beautiful. What I guess, I don't know, it's sort of surprising that this guy who was in the 21st century made that room on the right? Like, what is it about that building that room that is pretty to us? Can we name things about it that because, right, do we agree that room on the right looks nice?
Yes.
Yeah, what about it looks nice? Symmetrical? Yeah, that's a good thought. It's symmetrical.
It's natural light.
It's got a lot of natural light. This guy was a huge proponent of natural light. It was maybe one of the biggest proponents in the century of getting natural light back into architecture. It's made out of really nice materials, right? Lots of curves and a lot of big open space. And it also, to me at least, it feels like a very old building in some ways. Like, it's sort of surprising that this guy built this probably in the 70s. Because it looks really old, right? And it looks kind of like hand done, like the wisdom of its architecture kind of came from like past generations or something. That's kind of his whole deal. Is Christopher Alexander is this architect and this author who wrote these 2 really big and important books in architecture and in design in general. He wrote a bunch of books, but 2 of the biggies are The Timeless Way of Building and A Pattern Language. And they're kind of like sister books. They have the same cover. They were published around the same time. And they complement each other, okay? The difference between them is this is from an excerpt from A Pattern Language itself, so from the book on the right. This book provides a language for building and planning. The other book, The Timeless Way of Building, provides the theory and instructions for the use of the language. This book describes the detailed patterns for towns and neighborhoods houses, gardens, and rooms. The other book explains the discipline which makes it possible to use these patterns to create a building or a town. This book is the source book of the timeless way. The other is its practice and its origin. You know, now that wait, hold on. I'm actually confused which book he's talking about here. I know the timeless way of building is more about how do you create this mystical thing called a pattern language, and a pattern language is his example of a pattern language specifically applied to architecture. So, like, what is a pattern language, right? We've sort of thrown this around a little bit. What do you guys think a pattern language is? Either from what you've read from Christopher Alexander or from other design classes. Have any of you heard of the phrase a pattern language before? Yeah. I'm seeing you not. Yeah. What's a pattern language?
It's basically things that you do in a pattern that is understood by a group of people as a language can be used to communicate ideas. I've understood this in terms of branding and identity.
Yeah.
It's never just like a particular typeface that you're using. It is how you're using it, how you're pairing it with images, how you're showing it, when you're showing it. So it becomes a pattern of using it that can be understood as an identity language, and people can connect those dots to understand that it comes from the same brand.
Yeah, that's cool. I hadn't thought about it in advertising. That's totally true. Yeah, you create like a pattern and a relationship between like a font and a logo and like a placement, right, and different types of images. And when you have all of those at once, it sort of creates this concept of a brand, right?
Right. It could be done through multiple things. It could be done through a logo, kind of like Nike does it.
Right.
It could be done through mascots like Target does it.
Right.
It could be done through a phrase or tone like kind of Kit Kat does it, take a break.
Right. Right.
It can be done through multiple things. It could be done through colors.
Yeah.
Or like a particular typeface is
Yeah.
the most common example we
Yeah.
use.
Yeah, that's a really good example because it really does have the elements of a language, right? Because a pattern language is exactly that. It's a language of patterns. It's a language of different. It's a network of different patterns that are connected to each other and inform each other. And so, like in that example, you know, like there's all sorts of rules and patterns about how you would create a specific logo, and that's one type of pattern. Or the pattern of what type of font you would use would be another type of pattern. Or the pattern for like what the content of the font is, like what the tone is, right? Or the pattern for the layout. Those are all different patterns that work together to create a larger experience. Yeah?
I think in terms of architecture though,
Yeah.
I feel like what he's trying to say is there are certain things people are used to.
Yeah.
So
Yeah.
if you understand the essence of what they're used to and recreate it in a different way, if inherently they still see it as the same action, they're still going to use it. It's the theory of a doorknob. You can change the design of a doorknob, but it's still something you can grab and push down on. People are still going to accept it.
That's pretty good analysis. What do you guys think? Does that y'all agree with that or disagree with that? Is there something that, but like I guess the question, like the root of what a pattern is like what is the bare minimum requirement for something to be a doorknob, right? Like what is, like the pattern of a doorknob has to have some sort of intrinsic property or truth to it that everyone can look at it and be like, oh yeah, that's not a doorknob, that's a doorknob, as opposed to like, oh, that's a knife, I shouldn't touch that, right? If you put something that looks like a knife on the wall and expect people to use that as a doorknob, they're not going to touch it because it looks sharp and dangerous. But there's something about doorknobs, like that doorknob in particular actually does look close to a knife, right? But it's like round and cylindrical, so it's not as sharp. Like, I don't know, there's like,
Low poly knife.
it's a low poly knife. Yeah, it's a one-dimensional knife. I don't know.
I know people
Who use spoons as doorknobs,
like
or
brass spoons.
the
Antique brass spoons.
for doorknobs?
Yeah, like later.
That's cool. That is cool. Right. Yeah. Sure. Right. And like you have to do a certain amount of work to get somebody to look at that and understand that it's not actually a spoon supposed to being used as a spoon. It's a spoon in the place of a doorknob, and it rotates the same way. So yeah, it functions as a doorknob. So yeah, like a pattern language, I mean, this is in his own words, a pattern language gives each person who uses it the power to create an infinite variety of new and unique buildings, just as his ordinary language gives him the power to create an infinite variety of sentences, right? So each pattern is like a word in this language, and we can combine them in different ways to create new things. The elements of this language are entities called patterns, and each pattern describes a problem which occurs over and over again in our environment, and then describes the core of the solution to that problem in such a way that you can use this solution a million times over without ever doing it the same way twice. So like a doorknob, right? You need a way, doors need to shut, we need to open them. You need to be able to open them from both sides. So create a thing that you can twist that has a latch on it that goes through the door and is attached on both sides, so that when you rotate it on the inside, it also rotates on the outside, and it twists this little mechanism that pops in and that relieves the tension, and the door is on a hinge and the hinge swings open, right? That's like the pattern of a doorknob. I just kind of made that up. But I think that's like if we wrote down those instructions and gave them to an alien, they might be able to figure out how to make a doorknob, right? And patterns, the way that Christopher Alexander, like writes about them in like the way he sort of fills up this whole book with them, they have a really specific structure, and they all follow the same structure. So first, every pattern has a picture, like he does a little sort of, it shows like an archetypical example of the pattern. Second, there's an introductory paragraph which sort of sets the context of the pattern, which shows how it helps to complete certain larger patterns. We'll get back to that. Then there's like the beginning of the problem, and you sort of you talk about the headline, which is like the main, like a 2-sentence summary of what the problem actually is, the essence of the problem in 1 or 2 sentences. After the problem comes the body of the problem. This is a very long section. He sort of talks about like, it gives you a lot of context for what the problem is and what some of the steps are towards the solution. And then eventually you write the solution in a couple of really clear sentences. And then you talk about the smaller patterns that are needed to complete this pattern. Now, when we're talking about bigger and smaller, there's like another really important point, right? What's most important about this sequence is that it's based on the connections between patterns, right? Each pattern is connected to larger patterns which come from above it in the language, and to certain smaller patterns which come below it in the language. The pattern helps to complete those larger patterns which are above it, and it itself is completed by those smaller patterns which are below it. Does that make sense? What is that about? What's the deal there? What does like above and below mean? Sort of a really weird way to talk about patterns, right? But if you think about like the pattern for a classroom, right? For the pattern that was for this classroom, right? We have a big viewing space, right? We also have lots of workstations. We have a position for the lecturer to be where they can see everybody and they can all see him. And we have the pattern for lights and a door, right? And we already talked about our door. Our door has a doorknob pattern, and the doorknob pattern is like have a twisty thing that turns and unlatches the door, right? And so in order for the classroom to exist, it needs to have the door pattern inside of it, right? It is kind of like hierarchy. Yeah, it's like this idea that there are sort of things inside of other things inside of other things, and that like these patterns exist on small scales, and they scale up to bigger scales, and they scale up to even bigger scales, right? And so what's really cool about the pattern language book itself, well, I'll just keep going, right? So like each of these patterns, they don't exist in isolation. Each pattern exists in the world only to the extent that it is supported by other patterns. The larger patterns in which it is embedded, the patterns of the same size that surround it, and the smaller patterns which are embedded in it. This is a fundamental view of the world. It says when you build a thing, you cannot merely build that thing in isolation, but you must also repair the world around it and within it so that the larger world at the one place becomes more coherent and more whole, and the thing which you make takes its place in the web of nature as you make it. Okay, that last part gets a little weird, but like the idea is that everything you make, everything that you design is embedded in a context and has other things inside of it and has other things inside of it. It's like turtles all the way down. And that's a really sort of loopy view of like the built world, but it's also really beautiful. Because it's also kind of like genetics. Do we talk about genetics here? Yeah, it's like the pattern is, it's a thing which happens in the world. It's a rule which tells us how to create that thing and when we must create it. It's both a process and a thing, both a description of a thing which is alive and a description of the process which will generate that thing. This is all pretty abstract, but so, like to get really like concrete, like here's an example of how he uses patterns, right? Let's see, any small sequence of patterns you can take. So he has like 253 patterns in a pattern language book, and you can combine them together to create all sorts of things. Like you can combine them together to make a town or a region or parks or paths or workshops or gardens. So like he gives this example that like if you take these 10 patterns, so a private terrace on the street, a sunny place, an outdoor room, a 6-foot balcony, paths and goals, ceiling height variety, columns at the corners, front door bench, raised flowers, and different chairs. That short list of patterns kind of combines together to create a front porch, right? A porch. You can use those patterns of like, you should place flowers on flower beds, and you should have a bench near your front door, and you should have a ceiling at different heights, and you should have paths. Like if you combine all those different patterns together, you can get pretty good instructions for making a nice front porch. Yeah, we'll skip that. We'll skip this. But the point is, right, it's sort of like you have each pattern is sort of like a little genetic system which gives our millions of small acts the powers to form a whole. It's kind of pretty. So like, let's look at an actual like example pattern from the pattern language book. So the books are for free. They're not free. I found them on the internet. And it's not like the full book, but it's about like 80% of the book. So if you ever want to read it, it's a wacky read. So for instance, I'm just gonna go to like a random pattern near the back. He gets really, he's writing in the 60s, and a lot of these patterns are kind of wacky. Like he has a pattern called dancing in the street, which implies that we should dance in the streets more. But I'll show you like a more grounded kind of example. Stair seats. I like stair seats. Let's look at stair seats. So right here's this format that he's talking about. I don't want 2 pages. I want 1 page. Here's the picture of people sitting on the stairs. Each pattern has a name, so he names this pattern stair seats. Okay. He describes the oh God, what's happening? Why is my life like this? Okay, stair seats. This is the description of the pattern at the top. So this is the context, right? We know that paths in larger public gathering spaces need a definite shape and a degree of enclosure, with people looking into them, not out of them. Small public squares, positive outdoor space, path shape. Stairs around the edge do it just perfectly, and they also help embellish a family of entrances, main entrances, and open stairs. So these are like the patterns that this pattern contributes to. These are like the bigger patterns that this pattern is connected to. And the sort of root of the problem is summarized here, right? Wherever there is action in a place, the spots which are most inviting are those high enough to give people a vantage point and low enough to put them in action, right? So it's like, how do we create a public space where there's high spots where you can sort of observe things, but then you can be low enough to get involved? That's kind of like the problem, the design problem that he's sort of coming up against here, right? And so then he goes into it, we look for a vantage point that's removed and high up, but then we also want to get involved. How do I do this? I don't know. It sort of like talks more and more about like the in-depth rationale for why this could be a good thing. And then it sort of ends by saying specifically the solution to the problem, his design solution to this problem, is in any public space where people loiter, add a few steps at the edge where stairs come down or where there is a change of level. Make these raised areas immediately accessible from below so that people may congregate and sit to watch goings on. And here he has a little diagram of like, here's a public place, and here's stair seats. And this is the solution to this problem, right? And then he says, give stair seats, and then these are like the little patterns within the stair seats that help make good stair seats. So like, in order to make good stair seats, you should have them seats in the same orientation as seat spots, the seat spots pattern. You should make the steps out of wood or tile or brick so that they wear with time and show the marks of feet, and they're soft to the touch. So you should use a soft surface. And you should make the tiles connect directly to the surrounding buildings, like connect them to the earth. So that's just one example of like of a literal Christopher Alexander design pattern. Yeah? Any questions about like this structure? The usefulness of this? It's a little bit weird, right?
That's basically what we're doing.
In what way?
I mean, everything is kind of connected to make a big thing. And with signals too, it's kind of like that.
That's true, right? In Godot, we already have like this sort of idea of hierarchy and things inside of other things, right? Mm-hmm. Scenes inside of other scenes. So there's definitely a strong connection there. But even more broadly, if I were to try and get back to my freaking slideshow, where did it go? Where's my slideshow? Oh my God. What is today? What's happening? Where are you? Pause. Where the heck did it go? Well, I guess class is over. Open. Okay, great. Slideshow, presenter view. Oh my God. No. Stop. Okay. Right, here's another example pattern. This is literally from Wikipedia too, which is really funny. Here's a design pattern for how you get the perfect chocolate chip cookie. So you give it a juicy name like chocolate chip ratio. The context: you're baking chocolate chip cookies in a small batches for your family and friends. The patterns nested within it are like the sugar ratio, the flour ratio, and the egg ratio. Right, you're not going to make a good cookie at all unless you have a good balance of sugar and flour and eggs. The problem is like, how do you determine the perfect balance of chocolate chips in your cookie dough? And the solution is just, observe that most people consider chocolate to be the best part of the cookie. Also observe that too much chocolate may prevent the cookie from holding together, decreasing its appeal. Since you're cooking in small batches, cost is not a consideration. Therefore, use the maximum amount of chocolate chips that result in a sturdy cookie. Thanks, design pattern. You're just saying use a lot of chocolate chips in this cookie. But that's this is the solution to this problem. The problem is, how do I get the perfect ratio? The solution is just use as much as you possibly can. And then the patterns that this contributes to on the outside are like the nut ratio, right? You're not going to know how many nuts to put in a cookie unless you know how much chocolate you're putting in the cookie. You're not going to know how long to cook it for unless you know how much chocolate there is. And you're not going to know how long to freeze it for unless you also know how much chocolate there is in your cookie. I don't know why I left the presentation.
So you can also have like some patterns within a pattern, right?
Yeah, there's patterns. Every pattern has patterns like above it that are sort of that it helps create. And then every pattern also have patterns below it that are sort of necessary for it to exist. And it's kind of like on this, it's like this infinite scale that you can keep thinking about things on. I just want to go back to my slideshow. Why is this so hard today? It's because of the snow day. Okay. So, let's do this. Right, what do these have to do with XR? Firstly, pattern languages have many different applications across a lot of different fields, computer science and design. And we're going to build an XR pattern language ourselves, okay? The next chunk of time is going to be a workshop, but we're behind schedule, so let's just take a break now, okay? Let's come back. Let's try and come back really quickly at 4:55. That's in 10 minutes. And then we'll dive into a hands-on, like, design XR pattern workshop. Cool? Sweet. Thanks, guys. I'm going to stop recording.